Okay, a little more about the conditions here. This isn't the only condition we could use. We could say that also C over L is less than 4 over R squared. And we could then do the reciprocal so that R squared would have to be less than L over 4C. Okay. There are all kinds of ways we can rearrange this in trying to design our circuit. Again, we want this number here to be small enough, and of course this number is in reciprocal seconds. We want this number to be small enough that our exponential term, e to the negative r over 2l times t, doesn't go to 0 in a microsecond, although we might be able to observe that, or less than a picosecond, and we certainly couldn't observe that with anything that we have in this lab. Okay? So, that's kind of where we're at. We'll work out some more details of that. In the meantime, we want to deal with this wire. We want to see what the resistance of this wire should be. Okay? So, in order to figure out the resistance of the wire, we need to know its resistivity, its cross-sectional area, and its length. What we know about the wire is the diameter is approximately 0.5 millimeters. The mass is pretty close to 25 grams, I think. Mass density, well, it's copper. It's about 8 grams per cubic centimeter. And we don't need to get a really precise result for the resistance because we have other resistances in the circuit. Okay? So we just want a good ballpark so we know if we have, if we can set up an inductance and a resistance and so forth that actually works. So we want to figure out the length of that wire. So we'll continue with that and then with the analysis of the resistance of the copper wire.